Gypsum. It's one of those compounds that I get a lot of questions about, and I really hear a lot of misconceptions about how do we use it, what it's used for, and everything like that. First and foremost, we need to remember that gypsum is calcium sulfate. So we have a calcium tied to SO4 sulfate. It's one of those compounds that I get a lot of questions about, and honestly I hear a lot of misconception or misunderstandings about how can we use gypsum, how does it interact in the soil, and what does it do to the soil. Calcium sulfate is primarily used in the remediation of sodic soils. Now, sodic soil is a soil that has too much sodium in it, and it creates a dispersive situation that water can't go down because the sodium is large, and it prevents water from moving down. We use gypsum because the calcium sulfate breaks apart fairly easily within water, and we apply gypsum so the calcium breaks apart, displaces sodium off of the soil particle, and then we can flush it down with irrigation, rainwater, otherwise, and get the sodium out of the system. Another popular use for gypsum is in peanut production. Gypsum provides both calcium for the pegging and for the formation of the nuts, and then the sulfur is needed in legumes and the sandy soils, and also helps with the digging process. Now, one thing that I get a lot of that I try to correct people on is using gypsum to lower soil pH. Now, this is just not correct. It's not accurate. Gypsum, calcium sulfate, is applied thinking to lower soil pH because it has sulfur in it. Unfortunately, that's not how it works. We use elemental sulfur to lower soil pH. That's because elemental sulfur, when applied to the soil, turns from S in biological activity, turns it to H2SO4, so sulfuric acid. Once it goes into sulfuric acid, that sulfuric acid reacts in the soil solution, releases a hydrogen, leaving SO4. After that, so we've lowered the soil pH because we've added hydrogen to it, and we leave sulfate. Gypsum can't lower the soil solution with its sulfur because it's in a reduced form. So adding gypsum to lower the soil pH just is not going to do anything. We can see gypsum used in areas that have irrigation water that have high bicarbonate concentrations. So if you look just north of Stillwater in the Ponca, Blackwell, that region where we have irrigation water, irrigation area, you start on a field and the field's pH might start at about a 5.6 pH. After 10 or 15 years of having this high bicarb irrigation water, we're seeing pHs move to 7.8 to 8.0 range. So we have this increase in soil pH primarily due to the addition of bicarbonates. Now, if we were to add gypsum to this scenario, it would provide calcium to bind with the bicarbonate, because what we don't want to do is overload the system with bicarbs, because that calcium would start binding with the bicarbs that's going in, is going to bind with all the calcium in the soil, and at some point you're going to see that pH shift, and we're going to have a field that's really non-productive. So we can counteract the bicarbs in the irrigation water by adding gypsum. So yes, we're applying gypsum to a field that has high pH due to irrigation water, but it's not in efforts to lower the pH. It's in efforts to bind with the bicarbs that are being added in the irrigation water to prevent the pH from going up any higher. For more information, check out the SunUp website at www.sunup.okstate.edu.